In this question, we're being asked about a voltmeter reading if we were to connect a voltmeter to the terminals of the circuit. Before we get too deep into looking at the voltmeter reading, though, what we can do is simplify this circuit here into a simpler equivalent circuit and see what the voltmeter would read, reading the same terminals of a simpler equivalent circuit. So if we want to simplify the circuit into a presumably a Thévenin equivalent circuit, because then we'll have a voltage from the Thévenin circuit that our voltmeter will be able to read, we see that we have a voltage source in series with a resistor. We know that we can convert that into a Norton equivalent circuit with a current source in parallel with a resistor, and that should catch our eye because then we'll have a current source in parallel with a resistor in parallel with a current source in parallel with a resistor. So we can get a lot of simplification out of analyzing this piece of the circuit. If we want to replace this voltage source with a Norton equivalent, the Norton current is going to be the voltage that we have here divided by the resistance. And thus we'll have a 3 milliamp Norton equivalent current source. Also, one thing to notice here is the polarity of this voltage source. The current flows out of the positive terminal of a voltage source, and so if we want the Norton circuit to match this Thévenin circuit, the current source from the Norton circuit should be pointing downwards as well. So we're going to redraw the circuit, replacing this piece of the circuit with a Norton equivalent. Having redrawn the circuit, we see a couple things. We see that the current sources are in parallel with one another. If we have an 18 milliamps flowing up and we have 3 milliamps flowing down, we can cancel those and we can make a total net of 15 milliamps flowing upwards. Similarly, we have 12 kiloohms and we have 60 kiloohms, and we see that those are in parallel. Even though they're on different sides of the current source, really all three of these are in parallel with one another, and so we can combine these two in parallel to simplify the circuit. So we'll redraw the circuit with a simpler current source and with combining these resistors. We found a total of 10 kiloohms, which is in parallel with our current source, but this resistance cannot be combined right now with the other resistor that we have. But if we can convert this back to a Thévenin circuit, this 10K will be in series with the 15K and we'll be able to combine them. It will also get us a voltage source that will be better for considering the voltage that we'll see at those terminals at the end. We found that the equivalent voltage would be 150 volts because it would be our 15 milliamps times 10 kiloohms, and we use the same resistance in parallel is now in series. So we can take these two resistors in series and we can combine them to form one final Thévenin equivalent circuit. So we finally have our equivalent Thévenin circuit. And what we want to do is we want to connect a voltmeter to read at the terminals of this Thévenin circuit. And what a voltmeter is essentially a very large resistance that's connected. That very large resistance draws just a very tiny amount of current, but the voltmeter then reads the voltage across this 100 kiloohm resistor. So if we're connecting a voltmeter, what that means in actuality is we are connecting a 100 kiloohm resistor, and we're trying to measure what is the voltage across that 100 ohm resistor. In this case, if we want to know the voltage being applied here, well, we have a voltage source that's being applied to a pair of resistors. So we can use a voltage divider to find out how much voltage is going to end up being applied to that voltmeter. So the amount of voltage that we have here is going to be the source voltage, which is the Thévenin source in this case, times the resistance we're looking at, divided by the sum of the resistances. We can plug in the specific values here, and we find that the voltmeter should be reading 120 volts.